Okay, let's try and solve this problem now. Before I solve this problem, I'm once again going to plug in my message about the importance of practice. These problems will only get easier with practice. There is no shortcut, so please be doing that. Okay, so we've already looked at the first couple of problems. Let's now solve this one. Sears Tower in Chicago has an approximate floor area of 418,000 meters square, which now needs to be converted into square feet. So we need to go from meter square to feet square. Again, there are different ways, different pathways to follow. One of the suggestions I have, which I will use, is to go from meters to centimeters to inches to feet when solving this. We could of course go directly from meters to inches if you knew the conversion factor. If you knew the standard equation that relates meters to inches, you can use that as well. The other thing that I'm going to point out your attention to, that this is not meters, instead it's meter square. Similarly, that's not feet, it is feet square. So please keep that in mind. As always, we start with what's given to us, which is 418,000 meter square. If I want to cross out meter square, that goes on the denominator and then converts into centimeter square. If I want to now convert centimeter square, crosses out to give me inch square, and then inch square can be converted into feet square. But what about the values that go into the conversion factor? We know that 10 raised to minus 2 meters makes 1 centimeter. But does that mean that 10 raised to minus 2 meters square makes a centimeter? I mean, basically what I'm asking is this equation correct? No, that equation is not correct. If you're going to square or cube the units in an equation, you must also do the same to the numbers. In other words, these will also have to be squared. What is 1 square? 1 square is 1. So 1 centimeter square equals 10 raised to minus 2 square meter square. And that's important to remember. That this is a most common mistake to make, is to forget to do that, and I would urge you to keep that in mind. Similarly, we know that 2.540 centimeters make 1 inch, but if you're going to square the inch and the centimeters, then you must also square the numbers. 1 square again is 1, but then 2.540 square centimeter square. Using the same logic, 1 feet will equal 12 square inch square. Okay, so go ahead and pause the recording for a minute. That gives you time to calculate this answer. Hopefully you got the same answer as me, that is 449,9314.554 feet square. How many significant figures must this be written in? Yes, this needs to be written in 3 significant figures because of the area given. In other words, we need to round this right there. So this answer can be written as 450,000 feet square, but it has to be in 3 significant figures, so I can put an over bar on that 0, which makes it 3 significant figures. A better way, on the other hand, this answer is correct, but a better way would be to write it in scientific notation. That way you don't have to use over bars. In other words, 4.50 times 10 raised to 6 feet square. The answer in this case is in 3 significant figures. Okay, here's another problem. In this problem, we are given the distance from the sun to the earth. We're also given the speed at which the sunlight travels from the sun to the earth. We need to calculate the time that it will take for this light to reach earth. Now, question, how do we calculate speed? You calculate speed by dividing the distance traveled by the time it takes to travel that distance in. How do I know that's the case? How do I know it's distance divided by time? Because of the units. Units will guide you through a lot of things, guys. So please focus on the units. The unit of speed is in meters per second or miles per hour or kilometers per minute or whatever it is. In other words, the distance term is divided by the time term. Distance divided by time. If that is the case, if speed is distance divided by time, how do we calculate time? Time is calculated by dividing the distance by speed. In other words, the distance in this case given is 93 million, so 93 times 10 raised to 6 miles. We need to convert miles to meters so that the units of distance and the units of speed would match, allow us to cancel some things out. So miles can be converted into kilometers and kilometers can be converted into meters, and then divided by the speed. Now I'm going to use the speed as a conversion factor, even though it's not, it's given as a data, but I want to cross out meters and be left with time. In other words, meters will have to go on the denominator, and in this case seconds, because the speed is given in meters per second on the numerator. The speed given is 3.00 times 10 raised to 8 per second for every 1 second. Okay, let's fill in the numbers for the conversion factor. We know 1 mile equals 1.609 kilometers. We also know 1 kilometer equals 1,000 meters. Please go ahead and pause the recording in order to calculate this. Hopefully you also got 498.79 seconds, that the time that it will take for sunlight to reach the earth from the sun. This needs to be in two significant figures and therefore needs to be rounded right here, and the answer is 5.0 times 10 raised to 2 seconds in two significant figures.